All right, let's dive right in. Today, we are going from code straight to the cloud. We're going to walk through exactly how you can manage your entire Microsoft Azure infrastructure using nothing but Terraform code. We'll start with a blank slate and end up with a fully deployed environment. So let's get to it. You know the drill, right? You spend hours, maybe even days, clicking through the Azure portal, setting up servers, storage, networks. It's tedious, it's slow, and honestly, it's super easy to make a mistake. So what if you could just define all of that in one single file and roll it out with one command? Well, that's exactly what infrastructure as code is all about.
And our tool for the job today is Terraform. At its heart, Terraform lets you write these simple, easy-to-read files to define what you want to build. Think of it like a digital blueprint for your cloud setup. You write the plan, and Terraform becomes the builder that constructs it perfectly, every single time.
So where do we start writing this blueprint? Well, every single Terraform configuration file begins with a foundational setup block. You can think of this as laying down the ground rules for the entire project before we even start building.
And this is it, the Terraform block. Its job is pretty simple. It tells Terraform two critical things. First, what version of Terraform itself we need to run, and second, which cloud provider we're going to be talking to. In our case, that's going to be Azure.
Let's actually look at the code. See that required version line? That just makes sure anyone running this code is using a compatible version. But the really important part is inside required providers. We're defining Azure ARM, which tells Terraform, hey, go download these specific tools you need to talk to Azure. And notice we've pinned it to a specific version. This is so important because it keeps our builds consistent and prevents surprises down the road.
Okay, this next part is absolutely crucial, especially when you're not working alone. When Terraform builds things, it needs to remember what it did. But where does it keep that memory? That's where the backend comes into play.
So the backend block tells Terraform where to store its memory, which is called the state file. Now, instead of just keeping it on one person's computer, we're telling it to save it in a remote location, an Azure storage account. You can see right in the code, we're giving it the exact storage account name, the container name, and the file name with the key. This is a non-negotiable for team collaboration. It makes sure everyone is working from the same single source of truth.
So we've told Terraform which cloud provider to download. Now we've got to tell it how to actually connect and authenticate. This next block is basically how Terraform gets the keys to our Azure kingdom.
You know, the provider block itself can be surprisingly simple. All we're doing here is activating the Azure provider we defined earlier. Terraform is actually smart enough to automatically look for your Azure login credentials from your command line or other environment variables, so you don't have to put secrets in your code. And that empty features block? It's just a required setting that tells the provider to use all its default behaviors. All right, we've done all the setup. Now for the fun part. This is where we actually define the cloud components we want to build. And we do this using the most important block in all of Terraform, the resource block. Let's start with a basic building block in Azure, a resource group. Every resource block follows this exact pattern. You have the keyword resource, then the first string, Azure ARM resource group, is the official type of thing you want to build. The second string is just a local nickname you give it so you can refer to it later in your code. And then inside the curly braces, you give it the details Azure needs, like a name and a location. Now watch this. This is where the magic happens. We're defining a storage account now, but look at the resource group name and location arguments. We're not typing them in again. Instead, we're dynamically referencing the resource group we just defined. This is how Terraform builds relationships and understands how all your pieces fit together. Of course, we also give it the other settings it needs, like the account tier and replication type. And that little reference we just made, it leads us to one of Terraform's most brilliant features, dependencies. Terraform is smart. It reads your code and automatically figures out the correct order to build things. It just knows it can't create that storage account until after the resource group exists. This whole dependency thing comes in two flavors. What we just saw was an implicit dependency. That's the automatic one. Terraform figures it out because one resource references another. But sometimes you have a dependency that isn't so obvious from the code. For those cases, you have to be direct and tell Terraform yourself. That's called an explicit dependency, and you use the depends on argument for it. So here's what an explicit dependency looks like. We're creating a storage container inside our storage account. Now, technically, because we're referencing the storage account's ID, that already creates an implicit dependency. So the depends on block here isn't strictly necessary. But imagine you had a situation where a security policy had to be in place before a storage account was created, even if they don't directly reference each other. That's when you'd use depends on to spell it out for Terraform. Okay, so we've written our infrastructure blueprint. It's all there in the code. How do we actually make it real? This is where the Terraform command line comes in. There's a simple 3-step workflow that brings all this code to life. It really is a simple 3-step dance. First, you run Terraform init. You only have to do this once per project. It just downloads the Azure provider we specified. Step 2, Terraform plan. This is your safety net. Terraform shows you exactly what it's going to do, what it will create, change, or even destroy before it does anything. And finally, step 3, Terraform apply. This is your green light. You're telling Terraform, yep, that plan looks good. Go build it.
And here are a few other commands you'll end up using all the time. Terraform validate is a quick spell check for your code. Terraform FMT, or format, cleans up your code to keep it looking nice and consistent, which is great for teamwork. And for your automation pipelines, apply-auto-approve is a lifesaver. It just skips that "are you sure" prompt.
Now, remember that backend we set up way back in the beginning? It all comes back to this one thing, the state file. You could argue that this file is the most critical piece of the entire Terraform puzzle. Let's talk about why. The TF state file is Terraform's brain. It's a digital map of your real-world infrastructure. Every time you run apply, Terraform meticulously records what it built in this file. So the next time you run plan, it doesn't even have to ask Azure what's there. It just looks at its own state file, compares that to your new code, and instantly knows what needs to change. It is the absolute source of truth. So when you put it all together, what have we done? By defining our infrastructure in these simple blocks of code, we've created a process that's repeatable, that can be version controlled like any other software, and that makes collaboration a breeze. We've officially gone from clicks to code. The only question left is, what are you going to build next?